Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. On LCD display, we'll also write some text messages. So first we'll define text messages, and here I'll write text assignments. For this, we'll go to the help and we'll go to the LCD library, and from sample program we'll copy these 3 lines, that is to initialize LCD, clear LCD, and LCD cursor off. So I'll copy these 3 lines from here, Control C, and I'll paste these assignments before while loop, Control V. Now again we'll go to the sample program, and from here we'll copy that how to initialize text messages, Control C, and we will paste these messages here, Control V, and we'll modify the text according to our program. So here I'll modify the first text message, that is counter value, and I'll adjust the length of the message to 20 characters. Okay, and here is the message that we'll print on the first row of the LCD. Now I'll modify the second message to print the value of the counter on second row. So here I'll write 3 numbers, that is N and N, unit digit, 10 digit and 100 digit. I'll also adjust the length of the text to know that where to print the unit digit, 10 digit and 100 digit. Now here we can see that where to place the unit, 10 and 100 digit, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll write the unit digit at column 12, 10 digit at column 11 and 100 digit at column 10. Now we'll modify text 3 and text 4. It means that we'll press switch 1 to start the counter, switch 2 to stop the counter and switch 3 to reset the counter. So here we have completed our message assignments, and we'll write these messages on LCD in display routine. So here in display routine, I'll write that is LCD underscore out. First I'll describe the row, that is 1, and the column, that is 1, and the text, that is txt1, Control C, and I'll paste it here, Control V. So this command will print the first message on first row and first column of the LCD. Now we'll write 2 more text on LCD. So we'll write LCD out, third row, first column, and text 3. As we have to print the counter value on row 2, so we'll write the third text message on third row. Now we'll write on fourth row, that is LCD out 4, 1, text 4. Now we'll display the number on LCD at second row. For this we'll perform some calculation to divide the counter value in unit digit, 10 digit and 100 digit. So we'll add a calculation routine in our program. So before display routine, I'll call a calculation routine here, that is CLC underscore R, that is calculation routine, and here I'll write the calculation routine before LCD display routine, that is, and here I'll write the calculation routine, that is CLC underscore R, and here we'll perform some calculations. To perform these calculations, we'll use another variable, that is calculation register. So here in assignments, I'll assign another variable, that is unsigned character calculation register equals to 0. I'll use this register in calculation routine. And here I'll write calculation register equals to counter reg. And here we have the variable that is counter register. Control C. And I'll paste it here, Control V. Now we'll perform some calculations. That is 100 digit equals to calculation register divided by 100. To display the value of counter register on LCD, we have moved the value of counter register to the calculation register because we don't want to perform any calculations on counter register. And here we have divided the calculation register by 100 and we have moved the value to the 100 digit. Now we'll move the value to the 10 digit, that is 10 digit equals to calculation register divided by 10. As we have divided the calculation register by 10, so we'll adjust the decimal position of the digit and we'll write that is %10. So here we have adjusted the decimal position of 10 digit. Now I'll move the unit position digit of counter register to the unit digit, that is UNIDIG equals to calculation reg %10. And here we have moved the unit place digit to the unit digit. Now we'll write all these three digits on LCD on second row. So we'll go to the display routine. So here we'll write LCD character second row and 12th column and the value of unit digit, that is UNIDIG. Here we can see the number that is unit digit is a decimal number which can go from 0 to 9. But to print the number on LCD, it is required to convert the number into equivalent ASCII, and we can find from the tools of MikroC. We'll go to the ASCII chart. Here we can find to print the 0 on LCD, we'll write equivalent number, that is 48. Now we'll change the number to equivalent ASCII. And here we'll add 48. Now if this number, that is unit digit, will be 0, and if we'll add 48 to the number, it will be 48. And we can see the number 0 on LCD. Now we'll print the 10 position digit on LCD. So I'll copy this command, Control C, and I'll paste it here, Control V, and I'll change it to 10 digit. And I'll also change the position of the digit, that is 11. Now I'll paste the command once again, Control V, and I'll change the variable, that is 100 digit. And I'll change the position also, that is 10th position. And here we can find that we have written N and N on the positions at which we would like to print unit digit, 10 digit and 100 digit. Now here we have completed the display routine. Now after display routine, I'll call another routine, that is counter routine. Counter routine, counter, and here we'll add comments, that is switch routine. Now we'll write the counter routine before main program and after display routine. Now here we'll write counter routine, that is counter, and we'll check if SSFLG equals 1, It means that if SS flag is set, then our program will come into this if statement, and here we'll use the delay register to increment the counter after a certain delay. And we'll use this variable, that is delay register. So I'll copy it, Control C, and I'll write another if statement, that is if Control V, the delay register is less than or equals to, say, 10,000. Then our program will come into the second if statement, and here we will write Control V, that is delay register plus plus. So if the value of delay register will be less than or equals to 10,000, so our program will come into this if statement and it will increment the counter. But if the value of delay register will be greater than 10,000, so we'll write another if statement here. If Control V, that is delay register, is greater than 10,000, then our program will come into this if statement, and here we will write that reinitialize the delay register to the 0 value, Control V equals to 0, and here we'll increment the counter register, that is counter reg plus plus. So here we have completed the counter routine. If the SS flag will be 1, so our program will come into this if statement. So it will check that if the delay register is less than or equal to 10,000, it will increment the delay register and it will not come into this if statement. So if the value of delay register will be greater than 10,000, then our program will come into this if statement and it will reinitialize the delay register to 0 and it will increment the counter register. Here we have completed our program, and now we'll compile the program and we'll check if there is any error in our program. And now I'll compile the program. Here we can find that we have an error on line number 109, and the error is that we have missed the semicolon here. Now I'll place the semicolon here and I'll compile it once again. Here we can find another error on line number 130, and the error is that we have placed a colon instead of semicolon. So I'll replace this colon with semicolon, and we'll compile the program once again. Now here we can find that there is no error in our program, but still I can find an error in our program, that we have called a subroutine in a wrong way, and here we have to place brackets. Now it is a proper way to call a subroutine. Okay, now we'll compile our program once again. Now before downloading the program to the microcontroller, we will check that how much time will it take to increment the counter register by 1. For this we will use the debug tool of MikroC. We will go to the run and we will start debugger, and here we can find that we are in debug mode to debug our program. And here, before calling the counter routine, I'll place a breakpoint by pressing F5, and on this breakpoint our program will stop after executing 3 routines, that is switch routine, calculation routine and display routine. We'll add some variable in our watch window. So here in watch window we'll add some variables. So first I'll add port D, because we have connected 4 switches on port D. So I'll go to the select variable list. Here we have port D. I'll add to the watch list. Now I'll add the variable, that is SS flag. Here we have SS flag. Okay, add. Now I'll add delay register, and here we have delay register. Okay, add. And I'll also add counter register. Here I have the counter register. Okay, add. Now we'll check that by placing 10,000 in delay register, how much time our program will take to increment the counter reg by 1. So here first I'll set switch 1 on port D, and I'll assign the value, that is 224. It means that switch 1 is pressed. Okay. Now I'll press F6 and we'll see that SS flag will be set. And here we can see that our program is stopped before executing counter routine, and we can see that start stop flag is 1 and the time is 121.39 millisecond. Now I'll release the switch 1, which is connected on port D4. So the value of port D4 will be 240. Now if I'll press F6, the delay register will be incremented by 1. Okay, here we can find the delay register is incremented by 1 and the time is 161.06 millisecond. Now if I'll press F6 once again, we would be able to see that how much time our program will take to increment the delay register by 2. Here we have 161.06 millisecond. Now we'll press F6 once again, and here we can find the delay is 200.73 millisecond and the value of delay register is 2. Now we'll press F6 once again, and here we can see the value of delay register is 3 and the time is 240.39 millisecond. Now we'll press the function key F6 until the value of delay register will be 10. Then we can calculate the average time taken by our program to increment the delay register by 1. So I'll press the F6 function key to increment the delay register up to 10, 4, 5, 6, 7 and 10. Here we can find the total time is 518.07 millisecond. We will minus the 10 millisecond time from 518.07 millisecond, and 10 millisecond is the time which is taken by switch 1. 518.07 millisecond minus 10 millisecond equals to 0.50807 seconds. Now we'll divide this time by 10. So we'll get the time to increment the delay register by 1. So I'll divide it by 10. Okay, here we can find the time is 50.087 millisecond. Now I'll multiply this number by 10,000 and we'll get the time that is required to increment the delay register up to 10,000. So I'll multiply it by 10,000. So 508.0 seconds are required to increment the delay register up to 10,000. But we require that the time of increment should be 1 second. So we'll change this number and I'll divide 1 second by 50 millisecond. Here we have the time delay which is required to increment the delay register by 1, and this time is approximately 50.8 millisecond. So get the 1 second time delay, I'll divide the 1 second by 50.8 millisecond. It means that we have to put the number that is 19.6, but we'll replace this number by 20. Okay, now we'll stop the debugger and we'll remove all breakpoints. Now I'll replace this number by 20. And now we can debug again that how much time will be required to increment the delay register by 1. We'll compile our program once again. Again we'll debug our program. Start debugger, and I'll place a breakpoint before counter routine. F5. Okay. Now I'll assign the value that switch 1 is pressed on port D4. 2 to 4. Enter. And I'll press F6. Here we can find SS flag is set now. Now I'll release the switch connected on port D4. Then the value will be 240. Now I'll press F6 once again. Here we can find the value of delay register is 1. Now we'll see that if the value of delay register will be 20, then how much time will be there to increment the counter register by 1. And now if I'll press F6 once again, this delay register will be 0 and counter register will be 1. and here we can find that 954.43 millisecond, which is approximately equals to 1 second. It means that the increment in counter register will be after every 1 second. Now we'll compile our program and we'll download the hex file to the microcontroller. Okay, stop debugger, clear all breakpoints. Now compile the program. Now I'll connect the Picket3 programmer with the prototype. And I'll run the program for Picket3. I'll go to the file, import hex, and here we have the LCD counter project. Okay, open and write. Now we'll power up the prototype and we'll observe the result of our program. Here we can find text messages on LCD display, that is counter value, and on second row we can find the value of counter, that is embedded data. Third row we have text messages again, start, stop and reset, and here we have the switch assignment, that is press switch 1 to start the counter, press switch 2 to stop the counter, and press switch 3 to reset the counter. Now I'll press switch 1, and here we can find the counter is incrementing by a delay of 1 second. Now if I'll press switch 2, counter is stopped, and if I'll press switch 3, counter is reset. Counter start, counter stop, and counter reset.